Welcome to EPG Pathshala. I am Ravi Korisetter, Senior Fellow, Dr. V.S. Wakankar, Archaeological Research Institute in Bhopal. In this presentation, we are going to extend our discussion on lithic technology, but we will be focusing on the technology related to Mesolithic and Neolithic periods as part of paper 2 on pre and protohistoric cultures of India in the subject of Indian culture. The main objectives of this presentation is 1. To understand lithic techniques used in the last two Stone Age archaeological cultures, namely the Mesolithic and the Neolithic cultures of the Holocene period. We will study the lithic techniques used to manufacture blades, microliths and polished stone tools. It is generally believed that microlithic technology evolved only during the Mesolithic period, and that this particular microlithic technology during the Mesolithic period was an adaptation to post-glacial climatic conditions at the onset of Holocene period. The term Holocene refers to a geological time period which refers to contemporary time. Prior to the beginning of Holocene, major part of the earth went through Pleistocene period, and both Pleistocene and Holocene periods have witnessed the rise of Stone Age cultures. We see the gradual transformation from Stone Age to Metal Age with the introduction of copper as one of the raw materials for making stone artifacts. In spite of the introduction of metal as a raw material for making tools and implements, the use of microliths continues into later time periods, particularly during the Chalcolithic period and Iron Age as well. In addition, we also have to understand the lithic technology which has been inherited from the Paleolithic, Upper Paleolithic period. So as I mentioned in the beginning, it was not only during the Mesolithic period the microliths were produced, it has been documented from large number of sites not only in India but also in Africa and Sri Lanka that microlithic technology originated as early as 60,000 years ago, and there are sites in the Indian subcontinent and all including Sri Lanka where microliths go back to at least 40,000 years ago. We will also emphasize on repeating some of the slides from the previous presentation on development of lithic technology in order to make sure that you have sufficient grounding in understanding the techniques that were employed for producing tools of an entirely different kind. In the context of microlithic technology, we see that there is a major shift in the type of raw material that was used for producing microliths. Most of the cryptocrystalline silica rocks like jasper, agate, chalcedony, quartz and similar rock materials were the choice of the Upper Paleolithic and Mesolithic communities for producing microliths. This set of raw materials are also known as high quality raw materials as compared to the raw materials which were used during the Middle Paleolithic and Lower Paleolithic periods. And the production of microliths is also associated with the emergence of what we call modern human behavior. And more importantly, these microliths facilitated the formation of what we call composite tools. Microliths were hafted into grooves, and when they were hafted into grooves, they served a better purpose for harvesting wild grains which were seasonally occurring in the environment where these hunter-gatherer communities were living. In addition to that, we have another class of stone tools which we can now very clearly call them tools which were meant for producing food, and the tools which look very different from the tools which were produced much earlier, either in the Paleolithic or in the Mesolithic. We now get to see a series of stone tools which have a distinct appearance as well as morphology, and these tools are recognized as Neolithic stone tools because of the technology of production was new and the purpose for which these tools were produced was also different. While all the assemblages of stone tools from the Paleolithic and Mesolithic periods were associated with procuring food, we have this class of tools of the Neolithic period which were specifically made for producing food. So we are dealing with two groups of communities which were producing microliths and producing polished stone tools. That is one reason why these polished stone tools came to be categorized as Neolithic tools. The techniques of the preceding periods of Stone Age cultures continued in the Mesolithic and Neolithic cultures. Indeed, with appropriate addition and modification in the basic flint knapping methods and techniques. However, some specialized techniques like Levallois, Mousterian, etc. lost their significance in the context of Holocene cultures. The specialized prepared core technique, fluted core technique, which was developed to produce controlled flakes called blades, continued not only in these two Stone Age cultures under study, but also in the succeeding periods such as Chalcolithic and Iron Age. However, the length and width of the blades in the Mesolithic culture have reduced to 30 millimeters on average, hence called microliths. Such blades-based lithic industry is known as microlithic industry. The Neolithic culture witnessed the appearance of new types of tools called neoliths or polished stone tools, in addition to the microlithic tools of the preceding culture. Now, as I mentioned already, microliths were not produced for the first time during the Mesolithic period, and they have a long history, and they have a great deal of implications for understanding the behavioral aspects of hunter-gatherer communities of the later Pleistocene as well as Holocene. Microlith is a term used by archaeologists to classify a group of stone artifacts which measure not more than 30 millimeters in length, and they were made from such type of rocks called chalcedony, jasper, agate and quartz. In those areas where chalcedony occurs naturally in the rock formations as veins, were procured by the people for manufacturing microliths. This chalcedony has a glassy texture, and this glassy texture renders the blades which detached from cores with sharp edges. Now, these blades were not used directly because since they were used as composite tools, the blades were also deliberately backed, because the backed end used to go into the haft and the sharp end used to be put to function. So, series of such blades were hafted and then put to use. And microliths were not only blades, but there are several other kinds of forms, both geometric forms and non-geometric forms. The most distinct variety of microliths include lunates, crescents and points. These served various purposes, and microliths were also used as tips for arrows, where the bow and arrow technology was a commonplace among the hunter-gatherers of the Holocene period, particularly during the Mesolithic period. And then, as we just mentioned, Mesolithic period or the microlithic artifacts not only have a great antiquity, but they also have a longer history than other types of tools, and also the techniques which were very well put to use during the Middle and Lower Paleolithic time periods. Now, basic concepts of technology. Lithic technology, like other crafts, is a combination of two factors. The first is the method, that is the use of the mind, and the second is the technique, that is the use of hand. So, coordination between body and mind played a very important role in the emergence of technologies either in the Lower Paleolithic or in the Middle Paleolithic or during the Upper and Mesolithic time periods. It is always the case that both, unless there is a proper coordination between mind and body, you could not have given rise to any invention. Experiments and ethno-archaeological data have demonstrated that there are primarily two techniques, percussion and pressure techniques. We have seen the employment of percussion technique in the Paleolithic, direct percussion, indirect percussion and so on and so forth. But such techniques are no more in use in the context of production of microliths. So, punch technique also plays an important role in the production of blades, both microblades as well as macroblades. So, microblades came to be produced in large quantities during the Upper Paleolithic. Now, this indirect percussion and pressure technique were commonly used for producing microlithic blades. This kind of understanding of the production of microlithic blades is based on survival of microlithic technology among hunter-gatherer tribal communities living today in forests and hill areas of central India and elsewhere. So ethnoarchaeology has come to help archaeologists for replication studies of microlithic tools, and that is one reason why a combined study of stone tool technology in the light of ethnographic parallels helps us reconstruct lithic technologies in a very convincing manner. Prior to getting down to making any tool or artifact, its morphological features and the techniques that can be adopted to shape them must be conceived in the mind. Otherwise, one would not be able to make the desired tool type or artifact. This is not only applicable to the production of microliths, it is applicable to production of any tool as an artifact. Thus, before making something, there is present in the mind the shape of the tool and the technique to be adopted. So tool makers have got to be having a mental template of the artifact they would like to produce. Then only it is possible to develop suitable techniques to produce that particular desired shape of an artifact with the required length and breadth as well, including thickness. Therefore, if one is making a particular tool type, it means that one wants to use the tool for some particular end. What it implies is that every tool that you produce has a particular function to perform. So all artifacts produced by man, whether stone artifacts or metal artifacts or even earthenware pottery, they all have a particular function to perform. So unless they are functional, their production is of no value. Flint knapping technique that is employed for producing blades has two basic techniques. One is percussion technique and another is pressure technique. In case of percussion technique, either the object or the hammer is in motion. In the pressure technique, neither of them are in motion. As you can see from these two illustrations, the hammer is in motion and the point that has been used for secondary retouch is in motion, whereas the object which is held in the left hand is not in motion. Percussion technique has direct percussion technique, wherein the object which is to be modified is placed on the ground on an anvil, and then in the right hand you have the hammer stone that facilitates percussion activity. In another case, you have the anvil on the ground and the stone which needs to be modified into a particular form will be subject to percussion hitting the anvil which is on the ground, and the object which is to be modified will be rotated in order to achieve a sharp cutting edge all around the piece. So this particular slide gives you an idea of how percussion technique results in the formation of flakes, series of flakes. Now indirect percussion involves the use of punch, and the punch is used to generate long slender blades or elongated plates with the help of a soft hammer such as antler bone, or use of a stone hammer which is much lighter than the heavy spheroidal hammers which were used in the production of flakes, as well as detaching large number of flakes from the core to modify the piece into a biface and so on. And this slide also gives you a clear illustration of how this indirect percussion a technique is employed for generating blade tools. So as a result of removal of series of parallel sided blades from all around the piece of core, what you generate is that faceted core is the leftover thing, and the blades that were detached become important items for further modification into variety of microlithic implements. In this slide, we have three illustrations which demonstrate how the pressure technique is employed. In the first instance, you have a long shaft with a point at the distal end, which is attached to the shaft as a punch, and the pressure is applied by the chest. As a result, series of blades are also detached. In the second instance, on the left hand side of the slide, you have an example of how a blade is retouched by applying pressure. In the third example, you have an example of use of a pointed tool which helps in backing the blade or blunting the blade. So this is how pressure technique does not show any kind of an impact made through motion. Here it is only the movement of that particular tool to either give a secondary retouch or produce a back to the microlith. The most common technique that we come across in the generation of microlithic blade tools is the fluted core technology. And this technology was well suited in the context of use of high quality silica rocks like chalcedony, agate, jasper and carnelian and so on. But carnelian is rarely used for producing microliths, when most commonly we come across microliths produced from chalcedony and quartz raw materials. The illustrations very clearly show how these fluted cores have become part and parcel of archaeological assemblages. These are leftovers of blade production, and each of these fluted cores have a clear distinctive features such as a platform, flake scars, and then the point of percussion, either by direct percussion or with the help of a punch. Now that is how a series of blades were detached from all around the core, and as a result this has this faceted appearance, or that is why it is also called fluted cores. And most of the fluted cores have this kind of a pyramidal shape. Now all other illustrations in this particular slide give you an idea of secondary retouch. Primary step is to produce blades, and the secondary step is to produce working edges in the desired manner. So you have one side of the microlith blunted by applying pressure, another side of the blade modified to make it a sharp working edge. So we have these forms. We have a point, we have a triangle, and also a lunate shown as examples as a result of application of this particular pressure technology for producing microlithic tools. This slide demonstrates the way in which percussion technique helps in producing slender blades from a fluted core. Burin is a very important tool type, distinctive tool type of the Upper Paleolithic as well as Mesolithic period. Burin is otherwise called an engraver. Although these look like any microlithic blade tools, but they have a distinct point at one of the ends which have a beveled spall coming out from the end of the blade tool, and that has facilitated in the formation of a burin. Now these burins were largely used for engraving purposes, as known from a large number of Upper Paleolithic sites as well, and also Mesolithic sites. But blade and burin technology is most common and diagnostic of the Upper Paleolithic tools. So blade tools of the Upper Paleolithic were also made on flint and chert and such other materials, whereas microliths of the Mesolithic period were certainly made on chalcedony and quartz and similar rock materials. Now this illustration clearly gives you an idea how a burin, which is also a point otherwise, was produced by using microburin technology. Now we move from microlithic technology to Neolithic technology, where, as I mentioned earlier, we have a distinctive class of stone tools which are called food producing tools, and these stone tools are also called Neolithic cells or Neolithic axes. They are called Neolithic because of the typology, morphology and technique of finishing these axes. They were generally made from very fine-grained dolerite, gabbro, which are commonly occurring as dike swamps in the geological formations. This particular variety of rock, either dolerite or gabbro, was of particular choice by the Neolithic stone axe manufacturers. Although there were other varieties of rocks which occur in the environment, they were not used for producing stone cells, whereas other types of rocks were used for making different varieties of stone artifacts as well. For example, stone hammers, corn crushers, muellers, querns, such type of artifacts that we commonly find in the Neolithic context were not necessarily made from dolerite. Here, this choice of raw material was deliberate, and the location of workshops or factory sites where Neolithic axes were made were generally in proximity of the dolerite dike exposures. These dolerite exposures are very common in the granitic region of southern India and elsewhere. Even the dolerite dikes are also known from basaltic terrain. But as we know, a large variety of Neolithic stone axe manufacturing sites are associated with granitic hills in southern India. They provide us the best evidence to reconstruct various stages of processing a Neolithic stone stelt. There are 4 stages involved in the production of a Neolithic polished stone axe. The first and foremost step is to locate the occurrence of dolerite dike exposures. Now, mining blocks of dolerite was the first step. So, this procurement of raw material. Then after the procurement of raw material, these blocks of dolerite were subject to rough stoneworking or rough knapping in order to make sure that the block is suitable for further modification, which also involved 2 more steps. Most dolerites have a thick patina on the outer surface. So, this is otherwise also known as cortex. Now, in order to remove this patina on the surface of the dolerite all around, it was subject to what is called pecking. Pecking results in the removal of unwanted cortex material, and then the block of dolerite is given a rough shape, triangular shape, and that triangular shape is the essential shape to further modify that into a stone celt. After pecking, this particular form will be subject to further modification by removing flakes and reducing the thickness of the block of limestone, which has already achieved a triangle form. And then this particular form, at this particular stage, the artifact will be subject to grinding and polishing. Now, this is evident from the existence of grinding hollows in the vicinity of stone axe manufacturing workshop, as well as edge grinding grooves. These are found not on doleritic surfaces but on granitic surfaces. So, most Neolithic stone axe workshops are associated with the distinctive features. One is the outcrops of dolerite, another is granite boulder surfaces which having grinding hollows and grooves, and as well as cupules. Cupules are also facilitating the rounding of the butt end of the stone celt, whereas the working end is sharpened by using the granitic surface over a period of time that has resulted in the formation of series of grooves. Now, this is how a stone axe or a ground stone axe manufacturing was carried out in the context of producing polished stone cells during the Neolithic period. This technology continues even after the Neolithic period. In the early Iron Age also, with the coming of use of copper as well as other metals, and with the arrival of iron as well, we see that polished stone axe manufacturing activity continues to be an important craft activity among the Neolithic and Iron Age communities. So this series of illustrations which will follow now will give you an idea how the pecking activity was carried out all around the surface of the block of dolerite, and how then it was subject to grinding and polishing and so on and so forth. This illustration gives you an idea of how pecking results in removing and reducing the ridges to make the surface even, so that when it is subject to polishing or grinding, it attains a very smooth surface. And the final product of stone axe manufacturing, Neolithic celt manufacturing, will give rise to this particular form of Neolithic celt. It has a working edge and a rounded butt end. So another illustration which gives you an idea of the sequence of stages in making neoliths. In conclusion, I would like to say, to understand the rationale behind his or action, one should understand the process of cultural constructs through contextual archaeological evidence in time and space. The development of human behavior is not unilateral, rather multi-structural, multilateral, and spiral in time and space. At a more pragmatic level, it implies that there is some complex structural thinking process which links the possible visual patterns. An increasingly complex mixture of interdisciplinary knowledge has been required to keep pace. Why prehistoric man reduced the size of blades to microlith size? Why they took so much pain to removing the ridges and making grounded or polished stone tools? You may get some idea and explanations in the publications made by Prakash Sinha. In summary, I would like to say that in this particular presentation, we have focused our attention only on two distinctive class of artifacts. One, microliths, another is polished stone axes. Although there are many other varieties of stone tools which are manufactured during the Holocene, the focus was to explain complex technologies that were involved in the production of microliths as well as polished stone axes. And we also have learned from this particular module that the class of tools that were produced as microliths and the class of tools that were produced as Neolithic stone cells were meant for distinctive functions to be performed by the stone axe manufacturer or microlith manufacturer. While microliths are largely associated with hunting gathering way of life, stone cells and related polished stone tools and related artifacts were definitely associated with an entirely new life phase that were adopted by our Holocene ancestors as for food production. So the Neolithic stone axe and associated stone tools are related to a human activity which were focusing on food production from the Neolithic time onwards. Thank you. And if you study this particular model along with e-text and also the previous model, your understanding of the development of lithic technology from the Paleolithic to the Neolithic will be more and more clearer. Thank you.